This video presentation is going to go over specific heat. When we think of heat, we think of how can we increase the temperature of some object. Maybe it's your house and you're trying to heat up your house during the wintertime. Well, specific heat is going to help us to explain how much energy is it going to require to change the temperature in degrees Celsius. So on the screen is the definition for specific heat. It's the amount of heat in joules that is needed to raise the temperature of 1 kilogram of substance by 1 degree Celsius. And the units for specific heat are found on the right-hand side here, which would be a joule per kilogram degree Celsius. So let's take this further. On the right, you will see a table that contains the specific heats for some common substances. Water itself has a very high specific heat. It's 4,184 joules per kilogram per degree Celsius. So if you compare water to other substances, a lot of common substances, water actually requires more heat in order to change its temperature than a lot of other substances. So let me draw an example to help you understand. So if we have 1 kilogram of water, and we had 1 kilogram of iron, we want to know which one would heat up the most if we add a certain amount of heat. So let's say that both these substances are at 20 degrees Celsius already, which is room temperature. We're going to add 4,183, 184 joules of energy in terms of heat, thermal energy. So if we use what we know about specific heat, if we are at 20 degrees Celsius and we have 1 kilogram of our substance, and the specific heat of water is 1,184 joules per kilogram per degree Celsius. We divide it by 4,184 joules per kilogram degree Celsius, because this is the heat. So actually, we don't need that on it. So we're going to take the joules, and what that's going to do is going to, when we get 1 kilogram of that substance, it'll actually be equal to 1, right? So we actually increase the temperature of the water by 1 degree if we add 4,884 joules. So let's look at iron. So iron has a specific heat of 450. So put that in our denominator here. It is joules per kilogram per degree Celsius. And we're applying 4,184 joules of energy. So our joules will cancel out. We've got 1 kilogram of substance, so what we're going to end up with is a unit of degrees Celsius. We'll find out how much it's actually going to increase. So if we apply that to our calculator, we're going to take 4,184 joules applied to our iron horseshoe there, divided by 450, and our answer is 9.29. So let's say it's 9 3/10 of a degree Celsius increase. So when we look at this, it's going to be equal to 9.3 or 9 3/10 degrees Celsius. That's the increase. So over here, we're going to increase by 9.3. So 29.3 degrees Celsius. So if we apply this much heat to both these substances, if you can see, iron increases a lot more than the water because iron has a lower specific heat. This makes a lot of sense. Let's think back to maybe when you were making pasta at one point. Maybe you heated up the pan before you put water in it. The pan heats up quickly, where the water to boil the pasta heats very slowly, right? The water requires a lot more heat, more joules of energy than the iron. The iron heats up quickly. That's specific heat. Let's look at a textbook example. What is the change in thermal energy of a 1 kilogram water that is brought to a boil from a temperature of 22 degrees Celsius? Now, water boils at 100 degrees Celsius. So the temperature change is 100 degrees Celsius minus 22 degrees Celsius. So the temperature change is 78 degrees. So it's increased to 78 degrees. All right, so if we have 78 degrees as our temperature change, right, we know that it occurred because of some amount of energy. So our end unit needs to be some type of joules in terms of thermal energy. So we know that water has a specific heat of 4,184 joules per kilogram degree Celsius. And we know that we have 1 kilogram of substance. Right, so we take our calculator and plug that in. 1 kilogram times 78 degrees times 4,184. And the value we get is 326,352. Now that's an extreme amount of energy because water requires a lot of thermal energy in order to raise its temperature. So in problems like this, you have to find out what you're looking for. In this case, we're looking for thermal energy, and that's going to be the unit joules. Right? So we did get the right units here, right? And we can cancel out in our problem here degrees Celsius and kilograms, ensuring that we got the right setup for our problem. Let's look at one more example. This problem states the temperature of a 24.5 gram block of aluminum decreases from 30 degrees Celsius to 21.5 degrees Celsius. If aluminum has a specific heat of 897 joules per kilogram degree Celsius, what is the change in thermal energy of the block of aluminum? So let's look at the problem here and see what variables we have. We know the mass is 24.5 grams, and we have the temperature change, and we have the specific heat. And what we don't know is the thermal energy. So it should be in joules, as you can see all the answers here. The multiple choice are in joules. So this textbook problem has some situations with it here. We have grams and not kilograms, so we have to convert that to kilograms. And we have change in temperature, it's going to be negative, so we'll have to take the absolute value of that. So let's take a look at this. Let's start with the temperature. All right, so we're going from 30 degrees to 21.5. So, uh, so essentially we're going to get a negative 8.5 degrees Celsius, but we're just going to take the absolute value of that. So we don't have to worry about the change in temperature because it's just removing energy. And the other thing we have to convert is the amount of kilograms. So if we have a total of 24.5, sorry, grams of a substance, we know there's 1,000 grams in 1 kilogram. This helps us to change our units. So it's going to be 24 hundredths of a kilogram as our value, right? So just converting the mass. And we plug that into our problem. So we know that we have a temperature change of 8.5 degrees Celsius. Multiply it by our total amount of the material, 24 thousandths of a kilogram. And we have to multiply it by the specific heat of this material, 897 joules per kilogram degrees Celsius. Now, let's double check our units. Our units should cancel out because we're looking for a total of joules. And we'll know if we did it correctly. So here we got Celsius in the numerator and down here in the denominator, so those cancel out. And here I've got kilograms in the numerator and kilograms here in the denominator, they cancel out. So if I plug this in the calculator, we should find the right value. All right, So we've got 8.5 times 24 thousandths times 897. And the value I'm getting here is 100. Oops, so we get 186.5 joules, which is also 187 joules. So answer A here would be correct.